Hello, everyone. Good afternoon. Hope you are all enjoying the second day at I/O. Thank you for attending this session in person and by live streaming. I'm Indranil Chakraborty. I'm a product guy at Google Cloud Platform, and we also have Hanuk Kim, who's a product manager at Android Things for Enterprise. In this session, we're going to cover three key areas. What are the key products which Google offers for IoT, particularly as it comes to enterprise? We're going to talk about some of the key challenges in building IoT solution and how Google thinks about addressing those. And finally, we'll have some demos for you. So let's get started. Now, I think parking is a problem which is near and dear to everyone's heart, all of us. It is estimated that there are around 800 million parking spaces in the United States. The San Francisco city alone has 500,000 parking spaces, but it's still really hard to find parking. Now, the SF City has taken some initiative in putting sensors in many of the parking spaces so you can detect whether a parking lot is open or not. And that data is sent to cloud, and so you can check on your mobile phone which parking lots around you are open. That is great, because now you don't have to look around for parking, but you can just find parking and automatically on your mobile phone, and you park there. Now imagine if all the parking spaces in the US is connected through some sensor. While each sensor might be sending a small amount of data on a periodic basis, but cumulative, that is a massive influx of data. So the question is, how do we handle such massive influx of data, and how do you build applications which really scales? We also have some interesting partners who have built interesting applications for utilities. We have a number of smart meters in the US and in Europe, and this number of our partners and customers have connected the smart meter data from consumer homes, and now with Google Cloud Platform and with other applications, they can provide a pretty real-time view of the energy usage in different regions for consumers. Now imagine if all the houses, smart meters in all the houses are connected. Imagine the influx of data. There'll be millions of smart meters sending data every hour or every 15 minutes. That's a massive amount of data to handle. And what about security, and how do we get real-time insights? Those are all key questions which every developer has as they think about building enterprise applications. Google has done some work with data center optimization as well. As you know, we've collected data from HVAC, from coolers, from chillers in data centers, and we've used machine learning to overall improve our power utilization by more than 15%. Now imagine if every building, commercial and residential building, can use the same concept to actively optimize energy consumption. So there are some key use cases I just laid out in front of you. And I think you all know, while phones were bigger in terms of growth, phones are bigger than PC, a significant growth is expected for IoT in the coming years. Depending on the analyst report you read, it is estimated that around 20 to 50 billion devices will be connected by 2020. While each of these devices might be sending a small amount of bytes, so a small amount of data every couple of seconds or minutes, cumulative, it's a massive influx of data. So that creates three challenges as we think of and what we hear from partners and developers. One is security. How do you ensure that all these devices are secure? How do you ensure that all these devices have the latest operating system and the right security patches? And how do you ensure that the data which you're importing into cloud is protected and secured as well? Second is scale. When you have millions or billions of devices connected to cloud or to the internet, there's going to be a massive influx of data. So how do you handle all this data in a cost-effective way, and also make sure that you can manage this massive amount of devices which are globally dispersed in a way where you know that all those devices have the right firmware version, has the right security patches as well. And finally, what do you do with all this data? Each of these devices they're sending massive amount of data. How do you cost-effectively store the data? How do you analyze the data so you can get really actionable insight? And how do you also do it not just in the cloud, but also on the edge? So I'm going to start with how we think about these challenges on the cloud side. As you know, Google has 7 products which are serving more than 1 billion users currently. And all these users are highly engaged. So there's a massive amount of data back and forth between these products and as well as our cloud infrastructure. So as part of our mission at Google to organize world's information and make it universally accessible, we've been working with data ingestion, storage, and getting insight at massive scale over a decade. In fact, we believe, and in the process of serving these billion plus users for these consumer products, we have built the world's best compute infrastructure across hardware, software, networking, and operations as well. And we've built our infrastructure for developers in a way where developers think of these are not as data centers, but as one computers. All these data centers are connected via our global network. In fact, we are the only company, non-ISP company, who has under-ocean fiber connection between data centers. So as a developer, when you're accessing cloud platform and this compute infrastructure in the data center, it's not a collection of different data centers. For you, it's just one computer. You just write an applications, and cloud takes care of running them at scale. In addition to our data center infrastructure, we've also been working hard in building up our data management and analytics stack as well. Well, we built an open source MapReduce, Dremel, Bigtable, and many others over the last decade. And over the last couple of years, we've started to externalize these internal tools and this tech stack as services on our Google Cloud Platform for our enterprise customers, developers, and partners. So today, if you think, for example, think about BigQuery. BigQuery is our data warehousing and analytics cloud service. So when you run a SQL query on BigQuery today on cloud platform, your query essentially is running on Dremel, which we at Google internally use for our applications. When you upload some data on Bigtable, you upload it on a legendary Bigtable service, which has been used by Search, which has been powering Search, Ads, Gmail, and Google Maps since 2006. So everything that Google has built is in the process of being externalized, including TensorFlow and Spanner, which you're already aware of. So when it comes to IoT, we believe we have the industry-leading data analytics and machine learning services on cloud platform, which many of our developers and enterprise partners have been already using to build applications. And one thing they've asked us many times is, this is great that you have all these services like PubSub, BigQuery, Dataflow, Bigtable, but how do I connect and manage my devices and connect them to cloud so that I can start leveraging these cloud services which you have? So earlier this week, we announced Cloud IoT Core with a goal to make it really easy for developers to build enterprise IoT applications. So what is Cloud IoT Core? Cloud IoT Core is a fully managed service. It's 100% managed, running on Google Cloud Platform. Let's talk about security. As part of our Cloud IoT Core, we've built from ground up an MQTT protocol endpoint so that you can bring your existing device or your new device and establish a secure connection with Google Cloud IoT Core over TLS, and you can send and receive telemetry over MQTT messaging protocol. We understand that a lot of our enterprise customers already have devices that supports standard MQTT protocol. So we have built an MQTT protocol bridge so that you can connect your existing or new device directly to cloud and start leveraging our data analytics services. As part of Cloud IoT Core, whether you're connecting one device or millions of devices, the protocol bridge scales internally. You don't have to worry about provisioning a separate infrastructure or provisioning a node. You don't have to worry about redundancy. You don't have to worry about sharding. We scale internally. So that makes it, for a developer, really easy to build application without worrying about how do you scale from 10 devices to millions of devices as you graduate from a prototype to full-scale deployment. And the protocol bridge also underneath uses cloud PubSub, the foundation of data routing. Thanks to Cloud PubSub now, you can access the data which you have from your diverse connection of devices to Cloud IoT Core from a central point, so you can have a global view of all your data points across the different devices. We've also added some key functionality for device management. With Cloud IoT Core now, you can individually configure and manage devices, and I'll go more into the details. You can also now update and control the remote devices using Cloud IoT Core. We have built a set of APIs which you can use on your applications, and we also have a console so you can use that to manage your device as well. In addition, with Cloud IoT Core, you can provide granular level access to a group of devices and using Cloud IAM. So we're pretty excited with this release. We think this will really help developers, you guys, to start building using your existing device or even new devices running Android things or others to connect to cloud and start leveraging our data analytics and state-of-the-art machine learning services. Now, we understand that both developers and partners, as you think about building enterprise IoT applications, you want to build some quick prototypes to get your feet wet, see if there's an ROI before you start doing full-scale development. So as part of our Cloud IoT offering, Cloud IoT Core offering, we also have a UI which will be available on Cloud Console. Before I get into the UI, let me tell you about some of the key concepts for Cloud IoT Core, and specifically as it pertains to device management and monitoring. We have a notion of device registry. So if you are a device manufacturer and you have 10 categories of products, you can create 10 registry, and you can register all those devices for each of those category under a registry. And you can also assign IAM policies and roles to control access to users on those specific registries. So if I'm a device manufacturer and I want to make sure that my users in my customer A can only have view access, you can do that with our registry. And you can register one device or millions of devices in that registry. So as you can see on the screen, when you go to Cloud Console, there'll be a section. On the menu there's a section called IoT Core. You click on that, and you will see a list of different device registries which you have already created. You can also create a new registry, give it a name, select a region, and assign a PubSub topic which you want all the devices to publish their data to. And once you select on a device registry, you will see a list of devices which has been pre-registered, and you can see whether it's enabled or disabled. So with Cloud IoT Core, we also allow you to disable a device if you think a device has become a rogue device, or if you want to, for the testing purposes, you want to turn off a couple of devices and just have one device on so you can start testing the connection to the device. For the purpose of authentication, security is pretty close. We are very particular about security. So we wanted to make sure that as a developer, you can individually authenticate a device or a group of devices. So Cloud IoT Core has support for public key-based authentication, so asymmetric keys for authentication. And the way it works is you can register your device by adding a public key to Cloud IoT Core. And the device, when it wants to connect to Cloud IoT Core, it has to create a JSON web token of the public key and then send it to Cloud IoT Core. That is the identity of the device, and we use that to authenticate the device and make sure that the device which is connecting is really a real registered device. As part of our launch, we've also been working very hard with a number of device partners. So we're very excited that with the launch of Cloud IoT Core, we have announced partnership with a couple of key leading device manufacturers, such as Intel, Microchip, NXP, Sierra Wireless, Marvell, and many others. And we're working closely with our partners to make it easy for developers to connect partner devices to Cloud IoT Core right off the gate. For example, This is a really tiny microcontroller, ESP8266. And thanks to our partner, Mongoose OS, you can now connect a tiny MCU like this to Google Cloud IoT Core and start leveraging the data and ML services on cloud. So we're very excited about what we're building and how we're working with our partner ecosystem to really help developers so they can build compelling application. In addition to hardware partners, we're also working with application partners as well. So we've announced agreements with a couple of application partners such as Nubo, Helium, and a bunch of others which are coming along. So we're very excited with an announcement of Cloud IoT Core and how we're building partner ecosystem so that developers can really start building compelling enterprise application using Google Cloud Platform infrastructure. I want to spend a couple of minutes on some of the other services which really adds value. And as we think about the overall IoT platform, some of these services which are already existing today in cloud really helps you to build compelling application. One of them is Google Cloud PubSub. What's great about PubSub is that as for Cloud IoT Core, it sends all the devices which are registered to a registry, the data from all those devices are published to a Cloud PubSub topic. And what this allows you to do is you can collect data from all those devices into one topic and then start analyzing it using downstream services. PubSub has durable message persistence. What this means is, you can wait for 7 days to send a response back, or you can even send it within a minute. It also allows you to access data globally, as I mentioned. And what's great about PubSub is that now the Cloud IoT Core integrates easily with PubSub. It really separates the application development from your upstream device firmware changes. So you can constantly update your application, build new applications without needing to change your upstream firmware. And PubSub also allows you to use powerful services for building applications such as cloud functions, data flow, or even you can use your existing ETL pipeline or third-party services to consume the data from all these dispersed global devices and start building interesting applications. Once you've ingested the data in a secured way using Cloud IoT Core, and once you've routed the data using Google Cloud PubSub such that you have a global access view, you can then start using our cloud data services for analysis, storage, and insights. You can use, and this is where we want to have humans and machines learn from the data. So you can use BigQuery, which is our data warehousing and analytics platform, to analyze hundreds of billions of rows of data in a couple of seconds. And then you can use that data to train a machine learning model. So you can use Data Lab to analyze the data from BigQuery, connect it to Cloud ML, train machine learning models, and then eventually use those models to predict either power failure, demand usage, or maintenance, and then send it to Cloud IoT Core. And then from there, you can send it either send it some alerts, or you can even send it upstream to the devices as well. So this is how we think about our overall platform and how we think about the cloud portion as well as and its connection to devices. So here you will see you can use an Android Things device, which Hanuk is going to go more into the detail, or any other device any device with other embedded operating system. You can connect to Cloud IoT Core using MQTT and a secured connection to send your measurement and other telemetry data. All that data gets landed onto PubSub, on Cloud PubSub, from where you can then route it to either Cloud Function to build a simple rule and then act on it. You can do some complex event processing using data flow. And then you can use BigQuery or Bigtable to store data cost effectively, use it for time series analysis or for other ad hoc analysis, feed it to Cloud Machine Learning, Cloud ML, which is our managed service for TensorFlow, for training machine learning models. And then you can use the same Cloud ML for prediction, and then send the data back through Cloud IoT Core for any actions you want to take on the devices. So again, we're very excited with the upcoming launch, with the launch announcement of Cloud IoT Core More is going to come. We'll get more details. But I want to hand it to Hanuk, who's going to cover Android things for enterprise.
Thank you. Hello, everyone. Thanks. Hello, everyone. So I'm going to talk about the other side of an IoT solution, which is devices, devices in the field, which is also known as edge devices. And they're devices that are collecting information about your operations. In some cases, you know exactly what data you're looking for. And maybe you're looking for something that has high fidelity, something that has more accuracy, maybe more sampling rate. Or maybe there's a new sensor that came out that you want to apply to your enterprise solution. Or maybe you're looking for something, just a cheaper option at the end of the day. Or you maybe have a hypothesis that you want to try and test before you actually deploy and figure out whether you can actually identify new signals to drive better outcomes for your operation. Then you need devices to actually control your operations. And some of these devices are actually the same ones that are actually collecting devices. Some of them are not. They may be single points, and they may be multiple points. And they could be things like simple things like relays to hundreds of relays, or maybe even a single device that's purposeful in terms of like a controller. These devices are typically powered by either MCU-class devices, simple things like measuring temperature as an example, to SoC-class devices, which is a system on chip, which is typically much more powerful than an MCU and much more flexible. And those are the types of devices in which you want to have some on-device intelligence or maybe even complex operations. And types of devices may be things like cameras, gateways, point-of-sales machines, maybe even sensor hubs. And this last class of categories is where Android Things is here to play. We want to help our developers build these devices to be able to collect information from your operations, but also be able to control your operations much more easily and much more faster. There's already been a bunch of sessions on Android Things, so I definitely encourage you to look at the video streams. So I will provide you with a basic understanding of Android Things in the next couple of slides. So Android Things essentially is Android. We've optimized it for IoT. So essentially, we've taken out the components that aren't relevant for IoT. So as an example, things like user-facing applications, or maybe system UI, notification. And then we've added things that are very specifically that is needed for an IoT device. So things like peripheral I/O, user drivers, so they can add peripherals and components and devices as you need to. And in the process, we actually made Android Things also smaller, as IoT devices have a smaller footprint. For enterprise, I think the importance of Android Things, I think, comes down to 3 points. One is scale. So obviously, if you're already a developer for Android Enterprise, Android Things uses the same Android APIs and the same development toolkits, like Android SDK and Android Studio. If you're not familiar with Android, obviously, we've got a vibrant ecosystem that you can tap into, so you can start actually developing for devices relatively quickly. And Android OS is obviously very it scales to now we support over 2 billion devices across mobile devices, tablets, TVs, watches, and cars. And of course, many of these are actually in enterprise situations as well. And now we're adding IoT to that mix. The second is security. There was a session earlier today in the morning that actually did a deep dive on security. So again, if you're interested in the security, I encourage you to watch that video. So I'll give you a high-level view of security and how we think about it from Android Things. So we provide security through OS hardening, security in OS and app updates. So I think this is a very important piece because we want to make sure that the devices running Android Things are always patched up to the latest version, and you always have the ability to actually update your application that's running device-side specific software. We also support verified boot, signed images, hardware-backed keys, and attestations, and we'll continue to provide and work on security because we know end-to-end security from devices to cloud is actually very important. The last piece is, I kind of mentioned it before, which is peripheral I/O and user drivers. So this allows you to basically connect components, sensors, varying different input devices, displays, into Android Things and allow you to actually use those and actually build applications and devices across those things. Android Things is currently in developer preview. We're in developer preview 4, so we've done 4 releases. We want to do releases every 6 to 8 weeks, so we encourage you to kind of come along and play and check it out. We'll again do updates every 6 to 8 weeks. And then long-term support is targeted for end of this year, and it'll be based on O. So that's the software layer of Android Things. The next layer that I'll talk about is the hardware. So we know that hardware, bringing up hardware, new hardware is actually very hard and complex. So the approach that we're actually taking with our silicon partners is actually going down the path of what's called a SOM architecture. is a system of module. And the system of module comes with a couple of components. It comes with the CPU, memory storage, and connectivity. Essentially, all the pieces that you need to run Android things on. So you pick a SOM, it runs Android things, it's certified to run Android things. And from there, then you go ahead and build out what's called a baseboard, which has the additional components that you want to include. Things like I/O, display, sensors, and so forth. But because you've taken a SOM that's certified, Android things actually work. So there's no actually additional certification that you need to do. Right? So it helps you speed up your development cycle relatively rapidly. And obviously, we're working with a lot of silicon partners, as you see. And all these silicon partners obviously are also very trusted in the enterprise space. So for enterprise, what this means to me is faster speed to market. Right? We've certified these SOMs. They're proven to work on Android things. You take these and you can prototype relatively quickly and actually iterate on these designs. So most of these actual partners, silicon partners, also have developer kits as well that are available to you. And so in our demo booth, which I believe is A, which is one of the first demo booths as you come in, we actually have, we basically got a dev kit from Raspberry Pi. We've got a couple of components and a breadboard, and we simply just wired it up. And that is a device that's actually connected and actually working and actually sending information back to Cloud IoT Core. There's another version next to it, which is the next iteration of that, where we actually printed out a PSP board. We actually soldered the components on. So you can kind of see the evolution where you can go quickly from prototyping on a breadboard with wires into something that's soldered. And then when you're ready to go into production, because again, it's the same SOM, you can go scale right into production and then essentially scale all these devices throughout your enterprise to realize the benefit of your IoT solution. The last layer that I'll talk about on Android things is the services. We want to make it easy for you to use Google Services. We obviously believe Google Services can help you drive those insights that we talked about on top of your IoT solutions. Obviously, TensorFlow, you can use TensorFlow on Android things to run machine learning locally on the device. We also provide local-based services. And I also left a couple of the consumer services on there, like we support the Assistant. We are working on supporting CAS as an example. So this is important because in the cases of an enterprise developer, you may actually be developing both for consumers and enterprise, and we actually provide both. This platform actually supports both sides. And obviously for enterprise, I think the most obvious service that makes a lot of sense is actually Cloud IoT Core. Right? To be able to send data from Android things to Cloud IoT Core, to be able to apply data analytics, machine learning, and obviously then remote manage and control those devices. So in a case where you may have a sensor hub in a manufacturing line, or maybe even in a commercial building HVAC system, you want to be able to send that information to the cloud, analyze real-time usage, predictive analysis, anomaly detection, and then to be able to take your insights and then basically control those devices back to be able to optimize your yields or reduce energy. So how do you connect Android things to cloud? So we actually have a code sample that we actually created. And this code sample is actually an end-to-end code sample. We've actually connected a couple of sensors to Android things. We've defined the payload in terms of what data information that we want to collect and send that information through the MQTT bridge to Cloud IoT Core. So we basically show the full thing. But at the end of the day, it really comes down to a couple of core steps. One is create your Cloud IoT project, in which you need to define a project ID, registry ID, region ID. You go to Android things, you want to pull off that public key. So the sample code actually creates a public-private key, in which you want to create that, pull out that public key. And the private key then is actually stored within Android key store, so it's secure. The second step is then you want to register the device to Cloud IoT Core. And I've already shown you a command line method. Obviously, this doesn't work. This works really well for prototyping. But for when you want to go into production, obviously there's REST APIs that we can use. And we'll actually showcase a demo for you about registration and how important that is in terms of onboarding all these devices. And the last step is to essentially to configure a cloud service on Android things to start sending the messages to cloud. So relatively easy steps for you to use Android things and connect to Cloud IoT Core to use the power of cloud. And again, the code sample is on a GitHub, Android things, sensor hub, Cloud IoT. So now let's take a real example, or an example. So let's say you're building a camera. And maybe this camera is a quality control camera. So you have your specifications of what you want to achieve in your product, and you evaluate the different SOMs that we actually provide. And based on price, performance, you pick the one that works best for you. You build your product around those things. And it comes with Android things. So you build your APK to do the camera controls, the video data kind of capture and processing and streaming, and you connect it to the cloud. And what actually then becomes more interesting is the on-device intelligence piece, that little yellow piece, which is a TensorFlow piece. In the cases of quality control, especially in the cases of where they're abstract and maybe they're pattern-based, you can't actually define rules or they're learned. I can imagine a person at the end of a line that's looking at these widgets, and they just get smarter about and detecting like what's a defect versus a not defect. Those are all the same cases in which you want to be able to use machine learning. So as an example, maybe you're trying to define the quality of a wood grain, right? There's no specific rules about what good looks like, but when you see a particular wood grain, you know what that good looks like. Or maybe it's marbling on a piece of beef. As an example, you want to be able to grade things from A, B to C, and that's subjective. Or maybe it's a pizza line, right? And maybe it's hand-tossed, right? And you expect some variation in a pizza, right? You don't expect everything to be in the right place. But when you see this pizza, you kind of know what good looks like versus bad looks like, right? Those, again, good examples of where you want to be able to use machine learning. But you don't want to stream all this information back to the cloud because it's actually a lot of information. So this is, again, where you want to be able to use TensorFlow on device with your models to do decisions locally and only stream the information back to the cloud to enhance your models in the cloud. And as you make improvements into the model in the cloud, then you actually send the parameters back to the device to update the model. So you have this kind of constant iteration of making the models much better over time. And then you can use, obviously, Android things to make sure that the OS is updated to the latest patch, using your latest application. You can also use cloud to do remote management, so you can identify and alert yourself if one of the cameras is down. Or maybe you're just collecting quality information, and you want to be able to compare across 5 lines and see which one's actually doing better. And this scales if you have one camera or if you have hundreds of cameras. Or if maybe you want to take one camera and you actually want to retrofit your whole line with a whole bunch of sensors, so you can kind of get a sense of what the line is doing. So you can start thinking about correlations between what is the condition of your line and what are you defining as defects. So maybe you can get into predictive analysis around forecasting issues that come along. And that's the beauty of cloud IoT and Android things. It scales as you start thinking about the use cases. And as you add more use cases, you simply add on more sensors and more devices, and you stream that to the cloud. So to wrap it up, we're trying to make it easier for developers and partners to build enterprise IoT solutions from edge to cloud. Android Things really supports building out the edge computing for local controls, local alerts and notifications, data preprocessing, applied analytics, and machine learning. This will allow you to design a system that will improve performance. In the cases where you don't want to actually send data to the cloud and back, you can make those decisions locally on the device. Or build for bandwidth requirements. So if you have restricted bandwidth requirements, you want to do some processing on the device and send only the information you absolutely need to the cloud. And then lastly, be tolerant of offline use cases, whether they're either intended or even non-intended. Or you just need redundancy where you want to, again, make some local decisions on the device, but also make those same decisions in the cloud as well. So we're working on solving some of these key challenges through better managed security, scalability, insights. And so we're really excited about what do you think of Android Things with Cloud IoT Core. So I encourage you to invite you to test it out and give us some feedback. So thank you. Okay. So now we're going to go through demos. So the cameraman is going to come up and switch on the video so you guys can see from the live stream as well as the ones in the back. And on our demo board, we actually have three demos that I'll run you through. And the demos I'm going to run through is around registration, right? So registration inherently in enterprise is actually very challenging because the scale of registration it becomes very difficult because it's no longer about just one device, but it's about tens and hundreds and thousands of devices. And how do you effectively actually register these devices to Cloud IoT to stream information? So talking to our partners, we're going to show you basically 2 variations to show what the possibilities are. So we're going to focus on the right set of devices. And you can kind of see that from the screen, there's actually a QR code. And so we've actually built a mobile app for the demo to basically register. What the app will do essentially is, number one is, I'm going to sign in by myself, right, as myself, and it's going to check whether I'm actually authorized by Cloud IoT to actually add devices as an authorized user or not. So that's the first step. The next step is I'm going to go and capture the QR code as an example. So I'm going to go and capture the QR code. And this app is very simple. So it's basically got just 2 buttons. So I've captured the QR code, and the QR code basically gave me all the information I need to now register my device to Cloud IoT. So I use the REST APIs to now register that. So I'm going to hit Add Device. And then on the screen, where the internet is showing, is basically the device registry, and will show the device manager. And that device will now show up on that device manager. And then if you also noticed in Bear, you could see that the device actually turned on. And what the device did was as soon as it could actually talk to the cloud, it actually lit up the LEDs, and then we actually showed the temperature of that device. And now that information is actually streaming every second to Cloud IoT Core. So I'm going to go now and say, I put that on my machine number 1, or location number 1. So now I've got a second device. I'm going to do the same thing. Capture the QR code, and then add device. And the same thing, you're going to see it show up on Device Manager. and then soon you're going to see the device light up. As soon as it connects, and it's actually sending data. Again, it's sending every second, and so forth. So now I'm going to just continue to go down the line, capture the QR code, add device, go to the next one, capture the QR code, add device. Going to go and capture the QR code, add device. And the last one, again, maybe a different location, I'm going to go capture the QR code, and then add device. So every time I did that, you could see how quickly I was able to get 6 devices, see the visibility on Device Manager, and actually sending, again, data that are actually connected to Cloud IoT. Every second, I'm actually sending temperature data back to that. So that's one example of how you can actually register a whole bunch of devices. The second method is what's called pre-provision. So in this case, this is where the public-private keys are actually created in the factory. The public keys I actually provide to the enterprise. In the enterprise, we actually set those devices up in the back office. So what Indra will show you is the device manager will see a set of devices that are already registered, but they're disabled, right? Because these devices are en route. So what I have on my app, I'm going to use the app as well, is I'm going to go and query that device registry where it has all the devices in which we said these are pre-registered. Now I'm going to go install these devices in the places I want, and maybe I'm not ready yet, right? As soon as I'm ready, maybe I'm doing a test, maybe I'm doing production, I want to go and enable all these devices. So I have an app. Again, I'm going to have 2 buttons. One's disable and one's enable. I'm going to hit the enable button. And as soon as you do that, you'll see all the devices get enabled. And then as they get connected, they'll all light up. So we're going to do that. So we'll go bulk enable devices right now. So you can see that some of the devices are starting out to light up. And they're all lit up right now. So now those are 12 Raspberry Pis running on Android things. We also included the expressive boards running Mongoose OS. So again, they're a partner of Cloud IoT, and we did the same thing. So it's the same process. So this registry process is the same across OSs. We want to make this really simple for you to be able to register devices to Cloud IoT and to actually manage them in one place. So then now I'm going to transition to the next demo, back to Indra now.
Thank you, Hanuk. So Hanuk showed you a demo of how you can do batch registration, and you can even disable and enable a large chunk of devices which is manufactured. What I'm going to spend some time is giving you a demo on how you access data from all this global deployment of your devices, and how you can create some simple rules as well to take some action. So we have a dashboard here. What we have done is we have taken these sort of devices, a number of those devices, and we have deployed them across the Google campus in Mountain View, San Francisco, and in some other offices as well. So, and all these Raspberry Pi devices running Android things are connected to Cloud IoT Core, and they're constantly sending data about temperature, humidity, pressure, and other factors as well. And what I can show you is these are all the location of the devices. You can monitor, you can do real-time monitoring of all these devices in terms of the temperature and pressure. So the left chart shows you the local temperature for all this bunch of devices, the humidity and pressure. What we also have is a more detailed view, right? So I can click on a device, and I can see real-time what is the temperature of that device, whether it's an outside or inside, humidity, light, and pressure. And also, you can see this chart. It's actually moving in every second as it collects data from different sources and starts seeing it. So in the interest of time, I'm going to move to another demo where we're going to show how we need to switch to the split screen. Awesome. So we have, let me come here. We have a Raspberry Pi running Android things on this device, which is measuring temperature and light. We have an Intel Edison running Android things in a relay. And what I'm going to do is I'm going to put my finger here, which increases the temperature and also blocks the light. And you would see that the fan turns on. What's happening here is we have built the Raspberry Pi is sending data to Cloud IoT Core. Cloud IoT Core publishes it to PubSub, and then from there we have a cloud function which uses a simple rule to see if the temperature goes above 90 Fahrenheit. Then it sends a command back to Cloud IoT Core to turn on the fan through that Intel Edison. Now, what I can also do is I can turn it off from my UI as well. So all I have to do is, let's see, OK. Just say fan, let's say create a JSON on, so let's say fan on equal to false. And I just send the command, and the fan is turned off. So you can either use the system to create rules, either using Cloud Function or data flow to act on the device, send command, or you can do it from UI as well. So it's a quick demo of batch registration and how you can use connected devices, send to cloud to act on it, and then send commands and messages back to devices as well. Let's switch to the main deck so we can wrap it up. So we went through this. So in the summary, what you saw was we have Android things, which really takes care of security at the edge, managing those devices at scale at the edge, and also running actionable insights at the edge using TensorFlow. And we have Cloud IoT Core to connect your existing and new devices, such as even running Android things, securely to Cloud IoT, cloud, and then leverage our other services, such as PubSub, Cloud Function, Dataflow, and others, to have secured connection from device to cloud, run scalable app, build scalable application, and really get actionable insights. So next steps, we have helpful links. So if you are interested more in Android things, go to developer.android.com/things. Cloud IoT Core is currently on private beta, so you can go to cloud.google.com/IoT-core and request access, and we're reviewing access, and we'll provide you access over the next couple of weeks. So in summary, we're very excited with what you guys can do, and we love to hear your feedback, both on Android things and Cloud IoT Core as it comes to building enterprise applications. Thank you.
Thank you.